Hey there, welcome to this video on factoring trinomials of higher degree. In this video, we're going to build upon what you did in Math 2 with factoring trinomials using the product and sum method, and we're going to go ahead and show you how to do that with higher degrees today. All right, so that is our objective, and the step process that we're going to go ahead and follow is first to look for a GCF. It's important that we look for a GCF first because it will simplify or kind of reduce our trinomial that we're working with. Secondly, we'll want to go ahead and factor the trinomial into two binomials using the product and sum method. And I'll go ahead and kind of refresh your memory on what that is today. And then thirdly, we'll factor any difference of two squares from our binomials if that is applicable. Here is our first example, and we want to go ahead and factor this polynomial completely. So I'm just going to go through those steps. I'm going to say, okay, step one, do I have a GCF? Do I have a greatest common factor? And looking at this, I don't have a greatest common factor. There's no numerical factors, no numerical coefficients that all are the same. And variable-wise, not all terms have a common variable that I can factor. So for my GCF, I don't have any. I don't have to worry about that step here. Okay, step two, we're going to go ahead and do the product and sum method, okay? And if you forgot what that is we want to go ahead and say, okay, what two factors, a plus b, equal negative 25, and a times b, what two factors give us a positive 24, okay? So, and if you're unsure of kind of where this comes from, just think about it like this. I want to go ahead and I want to take my trinomial here, and I want to go ahead and factor it into two polynomials. Okay, now two binomials. So I need to go ahead and split this, and it's going to be x squared and x squared. Now, I know this is x squared because if I go ahead and multiply these, they give me x to the fourth. So kind of what you want to do is you just want to take your leading term and then take the square root of that. So the square root of x to the fourth is x squared. Okay, so I have these, and I want to know, I want to factor these into x squared plus a and x squared plus b. So if I went ahead and if I FOILed this out, right, x squared times x squared is x to the fourth, okay, and then x squared times positive b is a positive b x squared, okay, and then I had a times x squared, that would be a positive a x squared, and then a times b would be ab plus a b. Okay, and if I go ahead and simplify this, x to the fourth plus, I can combine these because these are like terms, so I have a plus b x squared plus ab. So again, here's what we're trying to do. We're trying to figure out, okay, what two numbers add up to give us negative 25, you can see that there, and as well as multiply to give us negative 24. Okay, and really, if you forgot the process of this, what you want to do is you want to break down 24. So what factors of 24 are there? So that's 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So those are my factors, and if I add all of those up, none of them add up to be negative 25. What do I do? Well, we also forgot the case of both terms being negative. I could have this being a negative, and this a negative, this a negative, and this a negative, this a negative, and this a negative, so on and so forth. So when this term is positive, when your AB is positive, that just means that these are the same sign. Okay? So which of these add up to be negative 25? And that is negative 1 and negative 24. Let's go ahead and rewrite our trinomial. So our trinomial is x to the fourth, Okay, and I'm going to rewrite my middle term. Okay, so you see how it's negative 25? Well, I'm going to rewrite that as negative 1 and negative 24. So that's minus, and I'll start with 24 so it's easier to see, negative 24x squared minus 1, and you can put the 1, you don't have to, normally we don't, minus 1x squared plus 24. And this step is important because a lot of people forget to go ahead and keep any variables in that middle term. So make sure you keep those. Okay, well, now I have 4 terms, and what I'm going to go ahead and do is factor by grouping. I'm going to group my first 2 terms, and I'm going to say, okay, what are any common factors there? And I have an x squared, leaving behind x squared minus 24. Okay, and then over here, do I have any common factors? And that would be a negative 1. So notice my leading term here is negative. I want to pull out that negative 1, and I have x squared minus 24. And I can go ahead and use reverse distribution. So I have x squared minus 1, x squared minus 24. Okay, and I have factored my trinomial. Now, third step. Do we have difference of 2 squares? And the answer is yes, we do. I do have a difference of 2 squares right here, x squared minus 1. So what I'm going to go ahead and do is I will factor that. That is x plus 1, x minus 1. And we are done. There it is. All right. Okay. I also want to go ahead at this point, and I want to point out, I want to kind of go ahead and draw a correlation between, notice the 2 factors that we picked out, negative 1 and negative 24. And if we look at our answer here, when we factored our trinomial, I hope you see the negative 1 and the negative 24. That is a shortcut. Okay, so if you go ahead and do it that way, you don't have to factor the 4 terms by grouping. You can go ahead and skip straight to the binomial. Okay, let's go ahead and look at another example. And here we are asked to factor this polynomial completely. So step 1, do I have a GCF? And in this case, we do. I do have a greatest common factor. So I'm going to put a little 1 here, and I'm going to say the greatest common factor is a 3. They all share a 3, and they all share an x squared term. So I'm going to factor out 3x squared. All right, well, what's left behind? So I divide 3x to the 4th by 3x squared, and I have x squared left behind. I'm going to divide my middle term, 3x cubed, by 3x squared, and that would be 2x. And I'm going to divide my third term, negative 24, by 3x squared, and that would be negative 8. Okay, so I have effectively factored out the greatest common factor. And now I want to go ahead and do step 2. I want to use, what 2 values, or what 2 factors add up to be 2, and what to multiply to give me negative 8. Okay, so again, you can go ahead and you can make a list, 1 and 8, 2 and 4, 4 and 2, and that's it. Okay, but see, notice now, this is negative. So these are going to be opposite signs. So if I have here, how about this, a negative 2 and a positive 4, that works. Another way that you can do this is if you just duplicate 4 times 2, 8 times 1, I can make each side negative. Okay, and this is only because this term, my product, is negative. So which of these add up to give us a positive 2? And that is here. So the negative 2 and the 4. Okay, so using that shortcut, I'm just going to go over here. I want to show you the shortcut really quickly. Okay, I'm going to bring my 3x squared, and I'm going to open up two binomials. Okay, and I'm going to take the square root of my first term, so I have an x and an x. And then what goes here? I want to see if you can predict it, okay, based upon that last example. So this trick, when we identify these terms here, we can go ahead and just drop them in here. X minus 2, x plus 4, and that is your trinomial completely factored, okay? Don't believe me? Let's go ahead and do it the long way that we've been doing. Okay, so I'm going to go ahead and rewrite this. Okay, I have an x term, so it's got to be linear. So minus, I'm going to rewrite this as negative 2x, positive 4x, minus 8. Okay, now I'm going to go ahead and factor this. So I have an x times x minus 2, and I have a positive 4 times x minus 2. Okay, and notice I used brackets just because when I go ahead and use lots of those parentheses, it gets kind of messy. So you use brackets, GCF, and then the brackets. That way everything is nice and organized. Okay, so now I can do reverse distribution. So 3x squared, okay, times x plus 4 times x minus 2. And I want you to go ahead and compare these two. So what do you notice? They're exactly the same, right? 3x squared times x plus 4 times x minus 2. They're exactly the same. I know these two are just flip-flopped, right? And that's fine. They can be that way because multiplication is commutative, but it's the same answer. So there is a shortcut, and I recommend doing the shortcut and using that. Okay, so now step 3. Do we have difference of two squares? And the answer is no, we don't. I don't have any difference of two squares in these terms. So this is our answer here. All right, so that is it as far as examples for this video. I'm going to make a second video where we have more examples, but I do want you to get some practice. So I'm going to go ahead and give you a practice problem here. I want you to go ahead and pause the video. Please try this, and then I will show you the answer. Okay, hopefully you have paused it. Here is the solution. Okay, and if you did the shortcut, that would definitely help you and save you some time if you identified -8 and 4 as your terms. Okay, here is another example. Please remember, use the 3 steps. So what do you have to do first, then second, then third? Okay, hopefully you pause the video. Here is the solution. Okay, and watch out for this landmine. They're going to try to trick you here to make you think that that is difference of squares. It's not difference of squares. There's a plus between those two squares. It's got to be difference of squares, not addition. Okay, next example. Here's the last example. Please pause the video and try this one. Okay, and here is the solution. So in this one, there was a difference of squares. So that is it. All right, hey, that is it for this video. I'm gonna go ahead and make a second video where we make it a little bit more complicated. We're gonna add in a leading coefficient, and this time our shortcut won't work, darn. But catch you in the next video, bye.